Welcome to the first video in our SIS2 networking video series where we'll be looking at the hardware we'll be using in this module. So to start off with, we have our base node. So this is the main piece of hardware we'll be using in the labs. It's made up of 3 Raspberry Pis, a router and a switch, and from that you can construct a series of interesting networks. To build larger networks, we need to connect to some other devices, and that's what's in this 1U rack. So here we have a cluster of Raspberry Pis and their switches grouped together to form some more interesting networks. So we've got a mail server, file server, and various compute nodes. In addition to that, we have some sensor nodes. So these measure the temperature, the humidity, and the atmospheric pressure, and we'll broadcast these onto our network. And we can also access it via other TCP-based protocols. The network we will be using in the lab is not connected to the internet for security reasons, as we'll be capturing packets and analysing them. So to allow our system to have a concept of time, we have an NTP time server, and on this big aluminium plate we have a GPS receiver. And that allows us to create a Stratum 1 reference clock, which the other nodes in our system can synchronise to. The main piece of hardware we'll be using in the labs is this base node. And this gives you a general purpose platform on which you can build different networks. It's created from 3 Pi 4s, and they are connected by their onboard NIC, network interface controller, to a MikroTik router. But they also have a USB to Ethernet adapter to give them a second Ethernet port. And that is connected around the back here to the front switch. So each Pi has 2 Ethernet ports, allowing them to do some routing. So we can set up Quagga, a software platform that will turn your Raspberry Pi into a router. In addition to this, the first Raspberry Pi, Pi 1, also has a real-time clock module added to it. This allows this Pi to run a NTP service, allowing the other 2 Raspberry Pis to synchronize their time to this reference clock. As we will be running these Raspberry Pis headless, we're not connecting a keyboard and monitor to them. We use some GPIO lines to allow us to see the status of each Pi and to allow us to reset it. So these are connected via wires to the front box. On this box we have a big red button. If you press that button, you'll shut down all the Pis. And we also can see the status of these Pis via the LEDs. So if the LEDs are orange, the Pis are shut down. If they're green, they are active. In the lectures I'll be using a slightly modified version to do some demos, and obviously a new and improved version with RGB because everything runs faster and is better with RGB. But also it's got an extra switch you can see mounted on the top here, so we can investigate things that you shouldn't do with a switch. The majority of the other network components are implemented in this 1U rack, which is in my office and connected to the lab by about 100 meters of Cat6 cable, so just within spec. And these are the various hosts and servers that you'll be accessing during the lab practicals. In addition to this Pi cluster, we also have our NTP server and some sensor nodes. So the NTP server is on my windowsill in my office, and alongside it is one of the sensor nodes. So our NTP server is equipped with this GPS receiver, and so it's pointing out my window to try and get a good line of sight to the satellites. And if the weather is good and all things are working, we can see enough satellites so we can get our position and time. This is displayed on the front LCD panel, and it cycles through general information that may be useful. Alongside it is the sensor node. We've got the sensor pod at the top there, containing our temperature, humidity, and atmospheric pressure sensors. These are read by the Pi down the bottom here, and again, this information is displayed on the front LCD panel. Obviously, in addition to that, you can also get this information across the network, receive broadcast packets, and directly connect via TCP connection to each of these servers to access this data. So for more information on each of these different nodes, do look to my webpage, and there's a webpage on each of them describing how they were configured and how they were built. So if you are inspired and wish to build your own, then all the design files should be there to allow you to build any of these Raspberry Pi systems.